Hello everyone, I am Sajid Hafiz and you are watching rprogrammers.com. In this video, we are going to create a basic guide for R programming. We are going to use RStudio and let's get into it. Okay, so that particular section is a scriptwriter where we write codes for our programming. In scriptwriter we can use our notebook files. We can also use simple.r script. This script is a simple.r script. We can only save codes in it, but in a notebook file or an RMD file, we can also save our outputs, and we can also add a lot of comments and a lot of basically it works as a latex. Okay, so let's move on to the other sections of the RStudio. This is a global environment. Whenever we save a variable, whenever we save a data set, we will see it from here. Like if just to provide an example, if I say sad is equal to 10, so basically I'm saving the number 10 into a name and I'm giving it a name as sad. Okay, so once I run that, I will see that there is a value saved with the name sad. So that's how global environment works. Okay, and this is the plot section. If I am going to create any kind of plot, I will see it here. Like if I just want to create a plot where on x-axis I am providing values like 1 to 3, and on y-axis I'm providing 10, 50 and 30. So once I run it, I can see the plot here. So just to introduce you with everything. Okay, and this is a console. In console, I can directly run the code without saving them. Like if I don't want to save, for let's say I am just want to calculate 45 multiplied by 39, I can just enter it and I will see the output here. Okay, so whatever you run from the script, it's going to be run in the console. Console is the thing that runs the code. The script is just helps you to save the code. If you want to save that file, you can just Control S and you can specify the location where you want to save that code. Okay, to replicate the results. After that, we have a file option here. From the file option, we can go to the import dataset. If we have a .txt file, we can import it from here. CSV files can be imported from here. XLS, XLS, or I'm sorry, from every kind of Excel files can be imported from there. SPSS files like .sav can be imported from this, and in the same manner, we can also import Stata and SAS files. Okay, so that's basically RStudio. Now let's jump to the R programming. I will try to make it as basic as possible that every single person can understand with zero knowledge of computer science and zero knowledge of programming. Okay, so let's start from, just leave this for the moment. Let's start from basic mathematics. So you can multiply, you can minus, you can add in the same manner as you do on your casual calculators. If you want to run that particular line of code, you just need to put your cursor anywhere on the line. You can run from here and you will get the output in your console. In the same manner, if you want to run the next line, you can just press run and it will keep on going. So additional is pretty much the same. 2 plus 2 is equal to 4, 5 plus 3 is equal to 2, 5 multiplied by 4 is equal to 20, 10 divided by 2 is equal to 5. It's pretty much the same. And 2 power 3 is basically 2 multiplied by 2 multiplied by 2, and that's why it's 8. Okay, now if I want to save any kind of these values into my RStudio to use them again in my code somewhere later, I can save it with this operator. Okay, so I'm just giving a name x is equal to 10, so I'm saving the value 10 and giving it a name x. In the same manner, I am saving y. Now I can use these references in our code to use. Like if I want to add 10 and 5, I can just say z is equal to x plus y. So it's going to understand that we are going to add the values in x and y. If I run it, I can see it from here that z is equal to 15. If I want, I can use print z. It will show us 15. And also you can also just write z and run it and it will show the same thing. Okay, So now come to the print command. Print command basically helps us to print something in our console. Like, and the second thing that I want to mention, that in the numbers, if we are talking about the numbers, we can just write the numbers, we can add them, we can subtract them, whatever we want to do, we can do. But in the case, if we are talking about the characters like hello world or any letters like A, B, C, D, for all these we say that it's a character type data in programming. Okay, and whenever we have character type data, we are going to use commas. You can use double commas, you can do single, you can use double quotation, single quotation is totally fine. Okay, and once you give it in the print, you will see that you can have hello world. And also, if you don't use print, you can also just run it and it will show you. Okay, so now, and one thing else that I want to mention is, whenever we are using small brackets, it means we are using some function. Like if we are using small brackets here, it means we are implementing some function on this. Like in that particular case, it's print. Okay, and whenever we use square brackets, it means we are referring to something. We will discuss it later in the same video. Okay, now let's move on to the data types. There are different kind of data types. Let's start with numeric. Numbers are basically numeric values. We just discussed how we can classify them, how we can save them in our environment. Okay, I just save a random number 42 and give it a name number value. Okay, and if I want to check its class, that what basically it is, I can just use a class function. I don't need to do print. It's not necessary, but I can do it if we want to. And it tells us that it's a numeric class. In the same manner, if we have character like words, we can use quotation commas and we can give it a name and we can check its class. Oops. And it's showing us character. Okay, and in the same manner, the third data type we have is boolean. In boolean, we have values like true and false. If we specify true, it should be all capital. Okay, so once I run that, and it will show me it's a logical value. Okay, logical values, it's going to be true, it's going to be false. Another thing that is basically the character type but in a different format is a factor. If we are discussing about something that is repetitive, in like if we have a data about males and female patients and there is a column of gender where we can see that there is only two types of character values, male, either they are male or either they are female. In that particular case, we are going to say these are factor variables, and to convert a factor variable, we will use a function factor here. Factor and this thing. Okay, there's the thing ceil, so let's discuss it before jumping up to anything else. We know if we want to save number, x is equal to 2, and by the way, we can also save it with x is equal to, we can also save it with this operator, it's totally fine. But this operator is more considered, this operator got more respect than the equal sign in RStudio community. And also, in some cases, we cannot use equal signs because equal signs have another purpose. We will discuss it later in the code in this video. Okay, so we can save a value by just giving it a name, x is equal to 2, and we can see x has the value 2. But if we want to save more than one value, like I want to save 3, 4, 5, 6, then I cannot just simply run like that. RStudio is not going to understand what is commas and what I want to say. So to save it in a vector format, we need to write C. C basically combines all of these values and save it as a vector. So once I run that, now we have an x. It has a length of 1 to 5. It means it has 5 entries and they are 2, 3, 4, 5, 6. So that's basically how C works. Okay. Now in that particular case, what we did is we created a vector with the names, 3 names, where one is male, other 2 are female, female. And we specified factors. we'll just give it a class. Okay, and once we run that, it says we have a factor value. It has two levels, males and females, and these males and females are getting a numeric value representative. Like in that particular case, male is getting a 2 and female is getting 1. After that, we have a data type date. Okay, so the one of the biggest reason to use R Studio is for time series analysis. In time series analysis, all we do is we deal with dates, we deal with the data associated with dates to explore the patterns and to explain all that, to explain a lot of things that change over time. To study that, there is another data type, date. Okay, so dates are not going to be considered as numbers, dates are not going to be considered as character, so they have their own format, and to convert it we can use as dot date. Okay, so since we are discussing as dot date, so we should discuss something else too. Now I know if I am going to create a call to save a value, I give it a name x, I run it, it's numeric, right? And it's 2. But if I add quotation marks around them, it means it is now a character, because we use these quotation marks around the characters values only. So if I run that, I will see something like that. And now if I run class on x, I will see it's not numeric. That's a character now. Okay, so if we are working on a data set, there are some values, like someone used O for 0. Okay, now this mistakes only will change the whole class of our variable or our data. So to convert such a cases to a numeric format, we can use as numeric. Like if I say x is equal to as dot numeric x, so it will basically convert the x value into number. So basically there are multiple functions as factor, as numeric, as date, that basically convert data type from one type to another. Like in that particular case, we are basically providing a string. String is basically character type variable that I'm talking about. Okay, and now we are going to change it to the date format once I run it. So that's it, it's a UTC and it's a date format. If I check the class of it, I can see it's a date. Okay, now before jumping to the packages, let's discuss something. In R programming, we can use the functions that are already built in R programming. Like we are using print function and it is already present in our R Studio. We don't need to install anything else for this, right? But there are some functions that are not in the R Studio, that are contributed from the community of R Studio. Like if I am working on some code, I will create a function, I will put it on the CRN, basically where everyone from the world can use these functions for their purpose. So these things are basically called packages, like a contribution from the community. One of the great thing about R programming is it has a great support from community. So it has a lot of packages. They are updating on the daily basis. They are creating new packages, and basically there's a lot of contribution from the community to the R Studio. Okay, now if I want to use some R package, I will come here on the package section, and in that particular section I will click, these are basically the packages that are already installed in my R Studio. Okay, if I want to install something new, like whenever we install R Studio or R programming on our system, we need to install the packages that we are going to use. Like if from here, if I'm going to import a package, so whenever we import a package, we use library and the name of the package, lubridate. Like in that particular case, we're using lubridate. Okay, and if I want to import that particular package, I must install it first. Okay, it's a one-time process. You don't need to do everything every time. You just need to install it for the first time, and after that you can just call it library lubridate and it will work. You will come here on install and you will just write the name of the package and it will pop out. Just click it and install it. But in my case, I have already installed it, so I don't need to install it. Okay, so once you install it, there will be some processing in the console. Just leave it for the moment. and once it's done, then you can just use it. Like in that particular case, I can run that line of code and it is installed. Okay, now we already did that, we don't need to do that again. But now if I want to extract the year from the date, I can just use the year function. Now year is coming from library date package, that's why we used that package, that's why we load the package. If I just run it, what I basically did is I just call the year from that particular date and we give it a name, year value, and we can see it here that year value has a value of 2021. Okay. In the same manner, we can also extract month, we can also extract date. Okay, now the new thing here is paste. So let me show you its output and then discuss it. Okay, so that's how basically paste function works. Paste function use a string that we want, like in that particular case I want to specify that this is a year. So for the explanation, I just write year dots, sorry, colon in the string format, and it's going to paste it with the year value, and this is 2021. That comma is not going to be printed, so you should know that. Okay, so these are all the different formats of data types. These are the different data types and different basics of RStudio. Let's get to the next section. We already discussed the vectors, so there is nothing to talk about. Okay, let's talk about this thing. We define a vector, we give it values like 1, 2, 3, 4, we give it a name VEC. Once we run it, you can run the code from here. You can also run the code with control enter. So if my cursor don't go to the run, understand that I am using control enter. We saved it, we run it, and we can see that we have values like 1, 2, 3, 4. If I want to extract something from a vector, I can just specify in the square brackets. Square brackets is basically that I discussed at the start, that square brackets are always used for reference. Okay, so in that particular case, I am just referring that I am going to get the value that is at second index in VEC. Like in VEC, we have 1, 2, 3, 4. At the second index, we have 2. So we are going to get the value 2. These are just small pieces of the code that we are trying to understand the syntax. Okay, once you're good with the syntax, then you can jump on to the more complex or more crazy codes, right? After that, we have a list. The main difference between the list and the vector is in a vector we can only save one kind of objects, like it should be number or it should be all characters. Okay, but in the list we can save different types of data, like one is numerics, is character, or is string, and a logical. We can save all of them into the list. For the list we don't need to specify C, we just use list here instead of C. You save it, you run it, and list will look something like that we have 1, we have E, and we have true. In the vector we only use a single square bracket, but in the list we need to specify 2 square brackets, and it will work pretty much the same. After that we have matrix. If you are from mathematics background, you must be familiar with the matrix. Okay, it's basically elementary mathematics, and I hope everyone is familiar with that. In a matrix, we can specify number of rows, we can also specify the number of columns. Like in that particular case, I just give it that I want a vector with values 1, 2, 3, 4. The rows of matrix should be 2, and all that stuff is in a matrix function, so I need a matrix out of it. Once I run that, I will get something like number of rows are 2, and we have 1, 2, 3, 4. And also I can also extract a single value from the matrix. Like in that particular case, I'm specifying at row 1 and column 2. At row 1 and column 2. So I'm going to get 3 from here. That's it. Until now, we are talking about the values, we are talking about the numbers, we are talking about the factors, we are talking about the characters, strings, and all that stuff. But from here to now on, we are going to talk about the data frames. Data frame is basically something like an Excel sheet with a lot of columns, a lot of values, right? Now we can also import them using import dataset and going through all these options to select the specific file. We can also create a data frame in our RStudio. To create a data frame in RStudio, we have a function data.frame. So what we are basically going to do here, we are creating a new object and giving it a name df. And in that object, we have a data frame. Now data frame, basically, let me write the syntax of the data frame. Data.frame is basically the function that is used to create the data frame. In these, we specify the name of column, and the values that are going to be in this. In the same manner, we can write second call values. We can add as many columns as much we want. Like in that particular data frame, we just give it a name. If we created the first column, we give it a name, and in the name column we have Elias and Bob. In the same manner, the second column we have age, and it has two values like 25 and 30. Once we run it, we will get a df. It has two observations, it means it has two rows, and two variables, it means it has two columns. We can print that from here. We can also double click here to see the data frame. So that's how our data look like. And we can also import our data set with the Excel file, as I told you earlier. So let's import the CSV file. So that's how it's look like. We can just click on the browse, and here we can select a file that is in CSV format, and we can load it. Okay, so I just select the file from my computer, and it's an Excel file with all these columns, as I can see. So that's it. I can just give it a name, like I want to save it as a data. If I want to skip first some rows, I can just say skip 5 rows first, and it will skip the first 5 rows. But it's totally up to us. If you don't want to do that, just write 0. First row as a name. The first row, if it has names, you can just tick it. If don't, you can just remove that tick. And first row is also considered as a data, and the new names like x1, x2 will be assigned. Okay, and open the data viewer. So once you load the data set, or data will be open on its own. If you don't click it, it will not. Okay, and similarly we have delimiter, like if we are using commas to separate, or tab too, so we can switch between them as well. And also you can fill the missing values with 0, with null, with NA, with empty, up to as you want. Okay, so once you're done with all that stuff, you can just click on the import, and data will be loaded and data will be shown to you like this. Okay, so that's how basically you can load the data set into R programming. Okay, so after that we have conditional statements, or you can also say loops. Suppose, so if you are familiar with any programming language, you should know about, you must know about the loops, like if, for, while, and all that stuff. But if you are not, it's totally fine. We are going to discuss it in this video. So loops are basically to do repetitive tasks in small code. Like if I want to print values, like if I want to print a lot of values, and I can just create a loop, and with the minimum lines of code I can achieve the same task that I will do. Okay, like in that particular case I specified x is equal to 10, and we say if x is greater than 5. Okay, so let's discuss the syntax first. If is, I'm commenting it, if is going to be, if I'm going to use if else statement, if is going to be, must be there. After that we will add a condition, and if the condition is met, we will do some operations. Okay, and after that we will say else. If the condition is not met, then we will do other operations. So that's the basic syntax of if and else. Okay, now you can divide that single line into 5 or into 4, totally up to you. So that's what exactly I have done. If x is greater than 5, we will print x is greater than 5. Else we are going to specify x is not greater than 5. Like in that particular case, x is equal to 10, so technically our code should print x is greater than 5. So once we run that, we can see x is greater than 5, right? So that's basically if else statement, and these are pretty handy when you're working on big projects. After that, we have a loop function. In loop function, we can loop over the different values to perform some operations. Like in that particular code, in the same manner where we have if condition, in the same manner we have for condition. Okay, and now I is a number that we can I here is just a word, that character that we can assign. Okay, basically it's kind of reference. Okay, so we are saying for I in 1 to 5, so in from 1 to 5, wherever we want to use these values, we will just write I, print I. So it's going to print all the values from 1 2 3 4 5. In the same manner, exactly the same, we have a while loop. In while, that's right, while and the condition and the operation that we want to do. If the condition is met, and this will do the operations within these curly brackets. Like if we say counts is equal to 1, and we are saying if counts is less than or equal to 5, print count, and count is equal to count plus 1. Okay, so what it will do, it is going to, once we run that, it is going to check if the count is less than 5, it's going to print count, and it's also going to add 1 into the count. Like it was initially 1, and after the first it's going to be 2, and after that it still again checks the value, and it's 3 now, but it's still less than 5, so it's keep on moving until the condition is met. That's why we're getting values like 1 2 3 4 5. So basically at the end of every loop we are adding 1 and we are printing the output. So this is the syntax of loops and how they works. After that, we have functions to replicate a lot of processing. Like if I want to some operations, I can also create functions. Like in print is a function that we are using from some other developer. In the same manner, you can also contribute to the community by creating your own functions and adding them into packages. Okay, it's not necessary that you need to add them to the package or you're creating them for that. You can also utilize the functions for your own utility. Like if I am going to do a lot of operations on the same data set every day, I can just create a function and call the function to perform everything instead of writing the complete code every day. Okay, so let's discuss about the basic syntax of function. Name of function. Oops. Please note that you cannot add sign into any of, sorry, you can, I'm sorry, you cannot add spaces into any name, not in value, not in anything. You cannot save anything with space in the name. Okay, so that's why you can use underscore. Okay, so the syntax is name of the function is equal to function, the inputs variable that it can take, inputs, and operations that you want to do, and at the end return. In return, you can specify what you want to show after running the code. Okay, so that's how basically a function works. In that particular case, we are creating a function to add two numbers. Add two numbers, it's just the name of the function, and the inputs are a and b, and the results return, it will return a plus b. So once I run that, function is created and it is saved. It's a function, add two numbers, it can take two outputs. That's how our function looks. Okay, now if I want to add any two number, I can just say add two numbers 2 and 3 and give it a name and save it as a result. If I run it, it will show me the output. Okay, so this is very basic syntax just for understanding, because we can also we don't need to do all that stuff to add two numbers. We can just write a plus b. So the main idea is to understand the functionality of function, that how you can you use them in your own codes. Okay, so after that, let's talk about some basic plotting. If I want to plot something, I want to plot a scatter plot, I can just use values at x, values at y, and plot xy. Like at x-axis, I'm going to say I'm going to use values 1 to 3. At y-axis, I'm going to use values like 2, 4, 3. And plot x or y will plot a scatter plot of them. Basically, what it puts the value 1, 2, 3 on x-axis and 2, 4, 3 on y-axis, and place it at every intersect point, like at 1 and 2, where x is 1 and y is 2. X is 1 or 2, we have this point. In the same manner, we have second point where x is 2 and y is 4. So in the same manner, it creates the points. Also, if you want to specify something from data set, you can use $sign to extract the column from the data. We will discuss it in this video, but later. Okay, so now let's talk about the descriptive statistics. Descriptive statistics is one of the most important thing to understand to the basics of your data. If you have a data sets and you want to check the statistical parameters like its mean, median, standard deviation, summary statistics, and all that stuff. Okay, for the mean, you can I just created a vector with the values 1 to 10 and give it a name sample data. Once I run it, I saved the vector, and with the mean function I can take the average of that whole vector. Like if I run it and the mean is 5.5, and we can clearly see it from here that its average is going to be something around 5.5. Now in the similar way, we have median. We can, instead of mean, we can use the median, and it's again 5.5. For standard deviation, we can use simply ST, and this is the standard deviation. In the same manner, we have a summary command that will perform all that stuff without doing it individually. Like if I just do summary sample data and I print the summary statistics, I will get something like that. That minimum value in our data is 1, maximum value in our data is 10. 25th first quartile or 25th percentile is 3.25. Like 25th% values are less than this particular number, and 75% values are less than this number. And in the same manner, we have mean, median. But for the standard deviation, we need to go through that approach. Summary statistics don't provide us with that. Okay, so after that, we're going to discuss about some data manipulations, that how we can play around with our data set, or how we can clean our data set to perform some analysis. So for demonstration purpose, I created a dummy data and I created 3 columns in it: name, age, and score. In names, we have 3 entries: Elias, Bob, and Charlie. Age is 25, 30, and 35. Scores are 85, 90, and 88. Once I run it, I save the data and base df, and that's how my data look like. Okay, now if I want to select some particular column, or I want to create a new data frame with only names and score column, what I can do is I can give it a new name, selected columns, and after that I'm going to give it a, okay, so let's discuss about the syntax. Name of the new data, that is going to be here, and after that the data that we are originally using, and rows and columns. So what basically we are doing here is we're providing a reference to the old data set that these rows are required and these columns are required. But if we don't provide any row, it means we need all the rows. Like in that particular case, we give it a new name, selected calls, and we are using the data frame that we just created, base TF. And in the rows, we didn't provide anything. It means we need all the rows. And in the columns, we provide name and score, that we need name and score from this complete data. Once we run it, we can see we just get two columns, names and score, and we drop the third column, age. In the same manner, we can also filter on the rows. Like if I want the values, if I want the data where age is greater than 27. So instead of columns, instead of rows, we will leave the columns as it is in that particular case, because we need all the columns. But in the rows, we will specify the condition that base $sign age should be greater than 27. So as I discussed earlier, that whenever we want to extract a column, a variable from the data, column, variable are basically the same thing. We call the columns as variables. Okay, so if I want to extract age from that particular data frame, I need to specify the $sign, right? So that's why I did base df $age. So basically we are giving reference to the data frame in the reference as well. So we are specifying every age. Whenever we have age greater than 27, it should filter out that particular data and save it as a filtered rows. So once I run it, we have filtered rows. There are two observations where age is greater than 27. In that particular case, it's 30, and in that case, it's 35. So that's how basically you can filter out your data. These are some basic level manipulations, but we will discuss advanced manipulations as well with using tidyverse package. Okay. And after that, we can also sort this data based on our columns. Like in that particular case, we have a base TF that looks something like this, and we want to sort this based on the score. So that's how base TF looks, and that's how sorted data looks like. So now we have the first entry with the max score and less than that and less than this. So that's how it works. Because, so let's break it down. That's data, name of the data. And in name of the data, columns, we are going to get all the columns. In rows, we are going to order them based on the score. And we add minus here so that we have maximum value at the top. If we remove the minus, we will get the least value at the top, and the sorted data will look something like that. Least, greater than that, and greater than that. So these are some basic manipulations. After that, we have a package, Dapplier package, that is present in tidyverse. Since you are using it for the first time, this code will not run as it is. You have to go to the packages, install, and you have to install the Dapplier package and click install. Once you install it, you can just run that particular line of code, library Dapplier, and your package will be loaded. Once it's loaded, we just created the same data set again with the new name. Okay. In Dapplier package, for selecting the columns, that we did something like this initially, that we didn't mention any rows, but we mentioned the name of the columns and we extracted them. We can use this function select. The basic syntax is, you can use select name of data, comma, columns that you want to extract. So once you run that, so in that particular line of cases, I just give it a name, selected columns in Dapplier, the name of the data that we just assigned, and I am selecting that I need name and score from here. I run it, it will show me the same output, name and score columns. In the same manner, we filtered at 27 using the references, but we can also use the filter function here. Filter, same syntax, just name of the data and condition. Age greater than 27 and it will work. And we will have a new data. In the same manner, you can also arrange the data set in descending order with arrange function. In arrange function, you will specify your data and you will specify the condition at what you want to arrange it. In that particular case, I'm saying it, I want to arrange it based on the score and it should be in descending order. We run it and it will be, that's it. Exactly the same thing, but two different styles. One is with the packages and the second one is using the main basic references. Now let's talk about the visualizations. We already talked about the scatter plot, but in that particular case, we are talking about the line chart. In line chart, exactly the same. We just specify what values are going to be on the X, what values are going to be on the Y. But here we also specify the type of the plot and it should be L. L represents line plot. So we will get a line something like this. But if we don't specify it, it will create the points plot that we already discussed. And also if we want to create a bar plot, we can just specify the values of bar and use bar plot function. And once we run it, we will get something like this. In the same manner, we can also create a pie chart. These are base graphics that don't need any external package to load to plot them. Okay. We can also create professional plots with advanced plotting package like ggplot2. You need to install the package in the same manner that we discussed. Once you are done with installing the package, you can go with library ggplot2. And we just, I don't know why I did it, but we created the data again. Okay, so let's discuss about the syntax of ggplot2. So the main function is going to be ggplot2. In that particular function, I'm going to define my data frame, and I am also going to define statics. Statics are basically is what we are going to put on x-axis and what we are going to put on y-axis. Okay, and after doing that, I will add a plus sign and I will specify the type of my graph that I want. Like if I want a bar plot, I just write geom bar or geom scatter or geom box plot, and there are different geom functions for different purposes. Like in that particular case, we use geom bar. Okay, so now take a look at that. We just say ggplot2 name. On x-axis, it's going to plot the names like names, Elias, Bob, Charlie. On y-axis, it's going to plot the scores like 0, 25, 50, 79, 75. And we also added stat is equal to identity. Stats is equal to identify basically helps the code to geombar to understand that the one variable is providing name and the other one is responsible for the score. Okay, because for the bar plot we only need numbers, we don't need the names. So that's why we need to, whenever we are using bar plot geom bar, we should specify the stats is equal to identity. In the same manner, we can also create geom line. For the line plot, every complete syntax is going to be the same, but at the end, instead of geom bar, we'll use geom line. And geom line can take both the arguments x and y, so we don't need to specify anything. Oh, for line plot, we need values at x and we need values at y. Like age and score should be better to run. Like we cannot use names on x-axis in line plot. We must have numbers on the both, and then we can create a line plot over here. After that, we have scatter plot. We already discussed it. We can use age and score. We can use, instead of geom line, we can use geom point. And we will get something like this. So basically, ggplot2 is used to create professional looking plots that can be used in professional reports, that can be used in scientific articles and advanced graphics. Like most of the plots that you see on your news channels are created in ggplot2. After that, we have histograms. In histograms, we can, in the same manner, need to specify the name of the data. We need to specify the aesthetics, that what is going to be on the x-axis, and we need to provide geom histogram, and its bin width should be 5. Once we run it, we will get something like this, and that's a one ugly looking plot. Okay, so bin width is basically to specify the width of our bars in histograms. Okay, to make it look better, we can use a fill argument. We can use call argument. Call is equal to white. So now it will create a white line on the boundary of the bars. So that's why we can see that particular white line. We can also give it a color. Like if I want to fill in a color in, let's say, sky blue, I would say fill sky blue. So once I run it, I will get something like this. Now, in the same manner, if I want to add a title to this plot, I can just plus enter and gg title, and in that this is the title. I mean, you can write it anything here, anything you want. So you will get something like this. In the same manner, you can also adjust the values at just the labels at x-axis and y-axis. You can just add another x positive sign. Xlab function is going to be used. Xlab, you can write anything you want. In the same manner, we can use ylab. And that's it. Okay, so code is running fine. We are getting the output. Our plot is much better, but this is not the right way to code. Whenever you are using a plus sign, you should went to the new line like this. So your code will be much more readable and it will be easy to understand and code will run. But if you press the enter before the plus sign, your code will show some errors. And also all these modifications that we did with color, with filling, with ggplot2, with labels, you can do with all the plots in ggplot2, like geom bar, geom line, geom point, everywhere. In the same manner, we can create a box plot. That looks like this because our data is not supported for the box plot. For the box plot, we should have a lot of values. Okay, so these are the visualizations with ggplot2. There is another package in our plotly, and you can also create interactive data visualization with this. If so, at first you need to install the package, and you know how to do that. Once you install the package, you can just load the package. Sorry, I just again created the same data set third time, and that's how the plotly that's how the basically the basic syntax of the plotly. We are going to use plotly, name of the data, what is going to be on the x-axis, what is going to be on the y-axis, type of the data, type of the plot, and name. So once we run it, basically we saved it in the fig bar, that's why it doesn't appear. I was waiting for it. So we need to run the name of this. And this is something like this. This is an interactive graph. So basically, if you go there, it will show you lice has a value of 50, 85 and 90, 88. So basically, you can zoom into some particular place like this. If you just double click and it will get back to reset. In the same manner, you can just select something like that and you can modify your plot. In the same manner, you need to specify the same thing, but in the type, you can specify scatter. In the mode, you can specify lines plus markers and name edges. And once you run it, you will get a line plot instead of this. Lines plus markers basically specifying, scatter basically specifying that you are going to create a point plot. Lines and markers are basically specifying that you are going to merge them with a line, and markers are basically the points. And name is edges. In the same manner, we can also create simple scatter plot without line. That's going to be look something like this. We can extract some point. We can double click to get back to our initial value. In the same manner, we can just change the type to the pie and we will get a pie plot like this. It's a one good package. In the same manner, we can create a box plot, but since our data is very small and it is not going to be worth. Okay, so in the box plot, we didn't specify any names, right? Once we did not specify any names, we are getting a same box plot for all three values. But the last time we did was we are basically creating three different box plot for three different names in ggplot. Yes, because we specified x is equal to name here. If we don't specify it, we are going to get a similar box plot. Let's do this again like this. So that's basically the difference between ggplot2 and plotly. But the good thing is in plotly you see a lot of explanations, like this is the median value, this is the first quartile, third quartile, this is the maximum, this is the minimum. So basically it's a one beautiful way to plot your data and to play with it using interactive features. So that's it for the video. Let's meet in the next video.